Well, hello, pre-calculus students and general seekers of truth. Let us walk into a problem here that's called the cosine of a difference formula. And I'm just going to ask you to kind of follow me along here. And at the end of the video and at some of the other following videos, I'll explain the significance of this. But let's say, for starters, that we have 2 points, right? Let's say we have the first point here, somewhere out here, and that has a radius of A, and this angle of rotation here, we will call that angle theta, right? So therefore, this rectangular coordinate here would be A cosine theta and A sine theta. And then we have some other point on the xy plane, and we get there by rotating with a radius of B, okay, and then rotating this angle here. I guess we'll call this angle beta instead, right? And so that means this coordinate here, the rectangular coordinates, would be B cosine beta, B sine beta. Now, what I want to do here is make some relationship between these points here and the angle in between them. So let's talk about the angle in between them. So this purple angle here that's in the middle, that between the two line segments here, this we can describe as beta minus theta, right? Because if you rotate beta and you take away theta, you end up with this angle in the middle here. And then if I were to connect this all together, I would have a triangle, and we can call this other side here C. Okay? Now again, this is kind of weird because I'm just kind of walking you through a proof, and we don't even know what we're proving yet, but I'm going to show you a derivation that ends up in something quite useful to us. So first thing I'm going to say is I'm going to use the law of cosines, and to kind of set all this up together. So the law of cosines tells me that C squared is equal to A squared plus B squared minus 2AB times the cosine of the angle in between A and B. So in this case, there would be this purple angle here. This angle is called beta minus theta. Okay, and this part right here is the most important part. So we're going to try to get some results, some useful results with that expression right there. All right, and again, asking you to follow me along here, and I will show you a result that is hopefully useful to you. Okay, so now I'm going to start out by just working on the left side of this. I'm going to use the distance formula. Okay, for C. So remember from our warm-up problem, the distance formula on this line segment here is d squared is equal to x1 minus x2 plus y1 minus y2, each of those squared. Okay, so we can apply it here for C. C squared, right, is really equal to x1, which is A cosine theta, minus x2, which is B cosine beta, all of that squared, plus y1, which is A sine theta, minus y2, which is B sine beta, all of that squared. Okay? And then I'm just going to expand on this a little bit here. So C squared, when I FOIL this out, I'm going to get some messy stuff. So I'm going to get A squared cosine squared theta minus 2AB cosine theta cosine beta plus B squared cosine squared beta. So that's this first part here, all right? Now if I use the second, when I expand out the second term here, so I will get A squared sine squared theta minus 2ab, got to be careful here, yep, sine theta sine beta plus b squared sine squared beta. Okay. Whew. So that's quite a crazy mess that we got ourselves there, okay? But rest assured there's a way out of this. So if you look at here, there are some terms that we could put together. So if we look at this term and this term, right, we could factor out, I'm going to just say c squared, still on here. So we can get wait a second, sorry, I messed that up. So let's try this again. So a squared cosine theta, that's going to match up with a squared sine theta. There we go. So we can factor out an a squared, and we would get cosine squared theta plus sine squared theta. Okay. Then you can see that we can have this part here, b squared cosine beta and b squared sine squared beta. So if I factor out a b squared, I get cosine squared beta plus sine squared beta. Okay. And then I still have the part in the middle here, that's the part that's sort of left over. Okay. All right, so this video is getting a little bit long, so I'm going to end it right here, and I'm going to pick up in the next video. But you can kind of see where we're going here, so I'll just add those two other terms here. So I'll get negative AB, negative 2AB rather, cosine theta cosine beta plus sine theta sine beta. Okay, so we're using the law of sines, and we're really so far not even using the law of sine. We're just using the distance formula and pull some polar coordinates to get to where we are. In the next video, I will finish this proof and get to some useful results. As always, ask for help if you need it. Thank you for watching, and have a wonderful day.